cover it one more time. So page 43, inscribed polygons. Yeah, so the idea here is we started, I'm just going to keep my finger on this page, right? I'm going to keep my finger on this page, but then I'm going to take you back to 33, where we started to talk about all the formulas for just regular polygons, right? Just polygons. So these formulas should be on your study sheet. Then on Friday or last class, we started to talk about inscribed. So what is inscribed? There are diagonals. Diagonals are in them, okay? Diagonals are, so we're cutting our original polygon, we're cutting it up, okay, with the diagonal. So the green one is my diagonal. So when you cut that diagonal, you create two different shapes in there. In this case, a triangle. You could just wait for now, okay? There's a triangle and there's a quadrilateral in this case, okay? So everything though hinges on, watch this guys, make sure you understand this. Everything hinges on the big original polygon. You gotta start with that, okay? So we found these angles here at the corners, okay? And so these are the interior angles. So when we, for example, look at the triangle, which is cut out of the original pentagon, we have one of the interior angles up there, right? The interior angle that we find here based on the pentagon. And what's the interior angle of a pentagon? We should know that one. I hope you memorized. That's 108, right? 108. So, and we know that this is an isosceles triangle, so we'll just go 180 minus one of those interior angles from the original pentagon divided by 2, and then we know these two angles, okay? It would be over here by the triangle, this angle right here. If we want to find this angle right here, we would consider this quadrilateral, the isosceles trapezoid that we cut out. And we know that all the interior angles of a trapezoid add up to 360. So we'll subtract two interior angles of the pentagon, the original pentagon, right? Like these two here. We subtract those from the 360 and divide the remainder in half. Then we get our two base angles here, okay? So that is kind of the pattern. And when you have a pentagon, isosceles pentagon, right? If the diagonal that you're using ends up giving you a pentagon, remember this is an isosceles pentagon, which means all these sides are the same, but not the diagonal. We know that it adds up to 540, and we subtract 3 interior angles from 540 and then divide it by 2 because we know these two are the same, okay? So these are the 3 formulas that I would like you to have on your study sheet. I is always based on the larger polygon. I don't know if you highlighted that part, but I will say that I is based on the larger polygon, not the shapes themselves, okay? So we started working with that. Okay, let's go over to page 44. I believe I did the first example, correct? I only did the first example on page 44, or did I do both examples? Just one? Just one? I get some confirmation. Okay, so I will do the bottom of 44, the second example on 44 with you. So you kind of you know that I like giving examples, but at some point I need you to also take over and do that. So let's focus on this one here. Dashed lines are not part of the original, okay, guys? So if you have a highlighter, I'm going to highlight the then I'm going to start with, there isn't a single angle in this mix. No numbers whatsoever. So that shape there is what I'm going to start with. I'm going to start counting here. 1, 2, 3, 4, 5, 6, 7. So n is 7. N is 7. Which one would make most sense to solve for right off the bat? Which angle should I start with? X here. What is this angle right here, X? What do we call that? It's an interior angle of that. What do we call a seven-sided? Heptagon, right? Yeah, so angle X is an interior angle. So I'm going to solve for X like this. I'm going to go n minus 2 times 180 divided by n. And so that would be 7 minus 2 times 180 divided by 7. That'd be 5 times 180 divided by 7. I don't have my key in front of me right now. It's a decimal, right? $128.57. This is important. I'm going to give that a color. Okay, so this one right here is that one right there. And if you want to write it in, why not? 128.57. Whether or not I asked you for this, that's the one you would have wanted to start with regardless. Okay, this one unlocks everything. And I'm going to use the green for my diagonal. I notice that I'm cutting, I'm creating inscribed polygons, like polygons that have two different shapes in there. If you wouldn't mind, I'm going to box this in. Just letting everyone know that's how I started. That's my very first angle. Let me just move out a little bit. I'll do Y here, angle Y next. This one. This is what? This is a trapezoid. Trapezoid, and I know that this is 128.57, and I know that this is also 128.57. Okay, once I find that interior angle, I know that these two are going to be the same. Okay. Okay, so to find angle Y, I'm going to use this formula. A four-sided shape has 360, a sum of 360 inside. I'm going to go minus 2 times the measure of one interior angle. And all of that gets divided by 2. Let's clean that up a little bit. Let's just do the top. Resist the temptation to do everything in one shot, and you're going to get it wrong. 102.86. Divide that by 2. That would be 51.43 degrees. What shape is created on the right side of the diagonal? 1, 2, 3, 4, 5, right? It's a 5-side. This is a pentagon. So I'm going to do angle Z next. How could I find Z? There's 2 ways of doing that. Ranveer.
So we know we get a y instead equals to 128.67 degrees.
That's
right?
correct.
We subtract y and
That's correct. So this whole thing is 128.57. Since we already know y, we can just find z like this. This is really the easiest method in my opinion. Minus angle y. So angle z is 128.57 minus 5143. And that is 77.14. Or, this is the long way. Or, this is a pentagon, right? Angle Z is going to be found by going 540 minus, because I know it's 540 all around. There are three 128.5 angles included. So I'm going to go minus 3 times 128.57 divided by 2. $540 minus 3 times 128.57. That's 154.29.
Excuse the interruption. Can we please have the custodian to the office? The custodian to the office, please.
This is 77.145. And I'm just going to do the whole, because it's not money, it's okay to do more than 2 decimals, as long as you do it correctly. Very, very similar. You're not going to lose any marks because one way is uses more decimal. It uses the decimal answer multiple times. That's why you're going to get a slightly different answer. So it's the same method there. Okay. I'm going to ask you to try. Let me see here. Did I do the one on page 45 on the video? I did? I think I did. So I'm going to ask you to try 46. Oh, I didn't finish 44 yet. I know that. But I'm going to ask you to try 46 once I'm done. As well as as well as 51 to 52, okay? So basically, if you haven't done it, if you haven't done so, you want to go, you want to make sure you complete 45 to 46, and page 51 to 52. These are mystery angles because I don't want you to forget about mystery angles like parallel lines and all of that stuff. Inscribed, and then this. And if you need a bit more review from the previous section, I'm going to give you one page from the previous section here. 39 and 41. 39 and 41. Okay. Make sure you have these ones written down. As soon as I'm done here, I would like you to do a little bit of work to kind of bring back things. And if you missed some of the notes, then this is your chance to catch up. I missed 2 angles, guys, on this one. Let's finish this example because it's important. M and N. M and N. Okay, MN. This one. And I took up a lot of space, so I'm going to try to make this work, okay? Angle M. What kind of an angle is M? What do we call M? Exterior, right? Exterior, because it's outside of this heptagon. Exterior angle. So it's an exterior angle. So angle M can be found by going 360 divided by the number of sides, which is 7. So it's 360 divided by 7. 51.43 degrees. Question, is there another way of finding this one? Yeah? The exterior angle is always 180 minus the interior angle, right? So that, because you remember these ones are always supplementary to each other. How do I find n? Well, just listen carefully here. These two are equal in length. How do I know that? Because this is an exterior angle and so is this one. This is technically also m here. So I'm just going to go 180, because it's a triangle, minus 2 angle m's. Okay? So I apologize, it's very tight here. So try to fit that in somewhere, if you could. So this is 180 minus 2 times 51.43. It's 77.14. Which coincidentally is basically the same as angle Z, but that's just a coincidence. Okay? Okay, you see those page numbers there? I'm going to highlight that because I want you to make sure you know what I'm expecting you to do right now. So keep that in mind.